Hello grade 12, welcome to my channel. So this year I've been lucky. I got some cry nice early ne awuthi siniphe cry nice sinibonise nje ukuthi nisebenze kahle bafethu ene konke besinifundisa kona kuvele bavela nje in a nice way. So I hope you guys are going to like this video and essentially are going to see how much you got in each paper. So in each section of this paper. So this is the November 2023 final exam. So let's have a look at it and see was it cry nice or was it not. But looking at it carelessly, even my student there already said this is the goal end, meaning it's just so easy, man. You just go in there, hey? I don't know if I'm interpreting this correct because I don't know what goal end means, but maybe it's just saying it's too easy. So I'm sorry guys, let's just go on for this one. Question 1. Okay, so we just go with 1.1 the standard way. 1.1.1. So we are given x squared plus x minus 12 is equal to 0. So this is our quadratic in standard format. So we will almost always win with factorization. But if we don't win, we have a quadratic formula. So what factors of 12? Between them we get 1. It's 4 and 3, right? Yes. So for this to be positive, 4 must get the sign of the middle term, and this one gets the sign of the last term. Okay, that's how it goes. So we go and say x is a 3 or x is minus 4. So the order in which you present these answers does not matter, honestly, but you can present them in ascending order. It's not a big deal. Easy stuff. So we're getting a mark here, we're getting a mark there. And for factorizing, that's the third mark. Easy stuff. So as I often tell you guys, check your answers. A mess on the signs can mess it up for you. So let's quickly check this thing. So this is going to be a 3 squared plus a 3 minus 12. Do we get 0? The answer is yes. What happens when we put a 4? So there's no time to lose these marks, guys. You don't want to unnecessarily lose marks because these marks are being given to you. So essentially when you put a minus 4 there, what do we get? 0. So it means our solution is correct. So we move on. A 1.1.2. We've got 3x squared minus 2x is equal to 6. Already we are told solve correct to 2 decimal places. That's already an indication that the roots are irrational here. So we've got to use our quadratic formula. But before we can use it, our quadratic has to be in standard form. Just a minute. Okay, so excuse me for that little bit of interruption. So our task here is to write our quadratic in standard format. So we transpose the 6 to the other side. This implies that x is going to be equal to, okay, maybe let's do it on this line. This implies that our x is going to be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so you should know this, guys. Second nature. Don't be hanging around. So b is minus 2 plus or minus. So you see, when you're doing the exam, there's no time to play. You just plug and go. B squared minus 4a is 3. C is minus 6.
3 is minus 6.
3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 is minus 6. 3 Okay, so we've got 2 into 3. So here, I don't hang around the bush. You can clean it up if you want. It's not necessary though, as long as you've made the correct substitutions. So let's see, we've got minus into minus 2 plus the square root of minus 2 squared minus 4 into a is 3 into c, which is minus 6. So the key step in this whole shenanigan is this substitution here, because if it is wrong, that becomes your enemy number 1. So I'm getting my x as 1, 79 to 2 decimal places, or x should be equal to, so with your fancy calculators giving you a break, instead of repeating this whole process again and perhaps end up doing an incorrect substitution, it's a nightmare. Minus 1, 1, 2. Okay. So those are our solutions. Again, make a habit, guys, of checking. So I know, it feels like unnecessary. You see, it feels like an unnecessary step, but the joy of doing this is that you know the answer is correct. There's no thinking about it. You know, you don't even need to be convinced by any memo, like what I'm doing now, to know that you did this one well. You should just know this one is in the bag. So I'm substituting 1,79 in there, and then I'm going to see if I'm getting a round number that is 6. That means we're going to round off to the nearest integer, and it's definitely 6, so it means this is correct. Okay, so you know that this is correct. So don't be lazy, guys. Trust in the process, because sometimes it's all that matters. It's all that matters. So here there's no time to waste marks, or else you're going to cry. See, now something is not right here. So I've got minus 1, 1, 2 all squared. Oh yeah, I forgot to put my 3 in there. Then I've got minus 2 into minus 1, 1, 2. Okay, this again rounded off to the nearest integer is 6. So this means, yes, these marks are in the bag. So guys, you have plenty of ways of ascertaining that you're getting the marks. There's no time to play here. So putting it in standard form, substituting correctly and those values, and you can see, you can actually check those values for correctness. Okay, so we've got our famous quadratic in set form, or this is what is called radicals. The EFF, this is the EFF. They like to make noise and end up introducing incorrect answers. So you need to check whatever the EFF says, you know. So they are like radicals indeed. Anyway, we know that in the next step, we've got to do inverse operations by removing the square root sign. So we just square there. Okay, this implies that we've got 2x plus 1 is equal to x squared minus 2x plus 1. This implies we just take this to that side and rearrange. X squared minus 2x is going to be minus 2x again, but I don't like to do unnecessary steps here. When you transpose this, minus 2x is going to be minus 4x. Take 1 to the other side. Actually, these guys will already cancel because they are both the same sign on either side of the equation. So this is what we have. This means we can actually take out the highest common factor, which is x into x minus 4 is equal to 0. Therefore, x is 0 or x is a 4. So let's see, when we put 0 in there, we get 2. 2 plus 1 is 3. No, you're lying. When you put a 0 there, it's going to be 0. So we've got 1. Square root of 1 is 1. Ne? Good. But when we put a 0 there, we get minus 1. So 1 is not equal to minus 1. So the left-hand side is not equal to the right-hand side. So we reject that solution. When we put a 4 in there, it's going to be 8 plus 1, it's 9. The square root of 9 is 3. Remember, this is regarded as positive when there's no sign before it. So some people will say, but I've taken a square root, so I'm saying plus or minus, but no, we treat it as a positive square root of this, essentially, because this is algebra now. All right, okay, all right. Let's go on. And then when we put a 4 there, we said we're going to get 3. 4 minus 1 is 3, so this solution is on point. So now, where are the rest of the marks? So we're scoring how many marks here? 4 marks. Obviously, this is an algebraic technique. It's being examined. So doing it, it's proper. Getting to this quadratic is proper. And rejecting the other solution is the 4th mark. Okay, great. Ama-cry nice. Hayi, benidla ama-cry nice. Sengiyabona ke manje. Ama-cry nice kuphela la. Ngawo nje wodwa 1.1.4. We've got x squared minus 3 is greater than 2x. Again, we can see we've got a quadratic inequality not in standard form. So we can't solve a quadratic when it's not in standard form, at least for inequalities. So it's going to be x squared minus 2x when we transpose minus 3 greater than 0. So which implies almost always it's going to work when we factorize. So this is x and x. So this is going to be minus 3 plus 1. And then at this point, I've taught you the graphical method. So this is the quickest, by the way. The graphical method is the quickest for this one. So yeah, let's just go for it. The table method is good as well. You can use it. But in the exam, guys, you always try to minimize wastage of time. But when you practice, you must know these things. Because if you don't know these things, you're going to get hurt, okay? So this means my turning point is going to lie to the right of the y-axis because this is negative. Remember, the x-coordinate is minus b over 2a, so this is already negative. So it's going to be positive, and that is positive. So I know my turning point is like this. So my graph is doing things. Of course, I know you're not supposed to necessarily go for this thing to be exactly accurate, but I don't like graphs that are not accurate. So this is going to be minus 1, that is going to be 3. And then of course, what do we say now? We want this to be greater than 0. So the x values that give us a value greater than 0 is these x values over there. Okay, these x values, you can see the corresponding y values are greater than 0. So what do we say? We can say therefore x must be less than minus 1, or x must be greater than 3. Right. No time to waste here. You quit wasting time. So what is the story here? You're getting a mark for this. Right. We're getting the mark for each solution and essentially the tool that you chose to use for this business. Okay. Easy 4 marks. 1.2. Okay. Simultaneous equations, guys. Stuff that you know. So we're given x plus 2 equals 2y. So it's almost always easy. This implies that x is going to be equal to 2y minus 2. We can make this equation 1, and we are given 1 over x plus 1 over y is equal to 1. So here we can also fix this one a little bit because they're giving us stones deliberately. So we know that what would be our LCM here? The lowest common multiple is going to be x times y times 1. So this is basically xy. So we just multiply throughout by xy such that when we multiply by xy here, x cancels. So we've got 1 over y is equal to, we multiply by xy there, y cancels. So you multiply by xy there, x cancels, we remain with y, plus multiply by xy here, y cancels, x remains. Here it's going to be xy. Okay, great. Here you don't need to sort anything, so we can say this is equation 2. We leave it like that. So we can say put 1 into 2. So we've got y plus x is basically 2y minus 2. Okay, is equal to, again, x is 2y minus 2 times y. So we've got y plus 2y minus 2 is equal to 2y squared minus 2y. So great, so we're going to move everything to the other side and rearrange. So we've got 2y squared minus, this one becomes negative. Actually, we've got 3y here because these are like terms, and then we transpose them. So 2y plus y, it's 3y. When we transpose, we're going to get minus 5y. Okay, minus 2. So when we transpose this, it becomes a plus 2 is equal to 0. Okay, let's move, guys. So we've got a quadratic here that we know most likely we will be able to factorize, but sometimes you may not. Just be careful. Sometimes they like to do things differently, but these brackets are both negative, so obviously this has to be a 2 and a 1, because 2 times 2 is 4 plus 1 is 1. So our shenanigan is factorized. So I know that my y is going to be a half, or y is a 2, and I know that I can conclude that my x is going to be essentially 2 into a half minus 2, or my x is going to be equal to 2 into 2 minus 2. Now that becomes 1. Okay, so 1 minus 2 is minus 1, and then here this is 4 minus 2, this is 2. Okay, all right, okay. Now again, guys, there is no excuse for not checking these against the original. Please try the original, because your manipulated expressions, you may have made a mistake, so it will check out and you think you are correct, but the original you did not manipulate. As long as you copied it correctly, then it should work. So let's put these values. When we put a half for y, what do we get? We get 1. Now the right hand side we've got 1. When we put a minus 1 in there, minus 1 plus 2 is a 1. So these ones check out for the original expression. Okay, then this one, we put a 2 there, we get a 4. We put a 2 in there, we get a 4. So these two also check out. So there's no excuse, guys, for getting these questions wrong, because you have means to check if everything is done correctly. And of course, we get our 5th mark by substituting one into the other. The manipulations are your problem, essentially. Okay, so let's go to 1.3. 1.3 says we're given here 2 to the exponent m plus 1 plus 2 to the exponent m. Okay, is equal to 3 to the exponent n plus 2 minus 3 to the exponent n. And we are told that m and n are integers. So where m and n are element of integers. Okay, great. Now we are told here determine m plus n. Obviously this question is an indirect calculation here. You have to first deal with this before you can deal with that. Sometimes you can deal with this and then it lands up into this, so you never know. But all you do, you start with what is given. So what do we do here? Our exponential rules apply here. So this implies we break this. If it is unified, you always break it, okay? You always do the opposite of what you are given. This is 2 times 2, okay? Plus 2 to the exponent m equals, again we break that up, 3 to the n times 3 squared. And then minus 3 to the exponent n. Nice. Now we can see that once you see terms in maths, you know that once we have terms, you are supposed to apply some kind of factorization. Here we need the highest common factor, which is 2 to the exponent m into, so this is going to be 2 plus 1, okay, is equal to, again we do the same here, 3 to the exponent n is the common factor. Then we get 3 squared minus 1. Nice. Now we simplify this bracket, so we've got 2 to the exponent m times, this is basically 3, which is equal to 3 to the exponent n times, this is 9 minus 1 is 8. Okay, so we can see here this base and that base are fine, but now we've got a base 2 there. We can express 8 as a base 2. So this implies that 2 to the exponent m times 3 is equal to 3 to the exponent n times 2 cubed. Now we can see this one and that should be okay, and this one and that should be the same if we have this situation here. So we can say here this implies that essentially 2 to the exponent m is going to be equal to 2 cubed. And we know for a fact that 3 to the exponent n should also be equal to 3 to the 1. Therefore, m is equal to 3. And of course, this one is going to be 1. Okay, great. So we can say then, because we were asked a question, m plus n is simply going to be 3 plus 1. Which is equal to 4. Okay, nice and easy. So that was a bit of a nice question. Tried to create a higher order question out of a very simple one. The key was that they wanted you to solve for m and n, but then they wanted something that is slightly disconnected from this expression. Of course, it's not exactly disconnected, but they wanted an indirect question so that you can find the intermediate steps by yourself. Okay guys, that was easy. 4 marks. Obviously finding the value for m and n is important, and the final answer is what is important. And to simplify to this step here was critical. Or you can even say the mark is here when you are equating these two, because the rest of the simplification is honestly your own indaba, but I think I would take this step as the critical step to our solution. So the simplification to that is good, is good, is good, is good. All right, guys, those were the 25 marks for this question. I'ma cry nice, my daughter. I'ma cry nice. I'ma cry nice. I hope all of you guys got full marks on this question. Otherwise, guys, I'm gonna do these videos as, you know, smaller nyana questions because I am tired. To do this whole thing is gonna be boring again because you have to focus on paper too. So I'll just drop single videos of each question so that you can just watch whatever question you want, and it's gonna be a bit easy to do without tapping onto your time too much. Okay, guys, I hope you enjoyed the video. Goodbye.